All right, thanks everybody for coming. Let's give everyone another minute to join us, and then we'll get started. All right, everybody, thanks for coming. This is session 3 in ClearBlade's ClearLab series. This is a series of 30-minute seminars we're putting together to help developers who wish to build IoT solutions using the ClearBlade platform. Now, just as I did last week, I'm going to ask you guys to find the email that invited you to this session. In that email, near the bottom, you'll see a link with the words "Learn More." I'd like you to click that link, and the page that it leads to, I'd like you to please leave that open in a browser tab. We're going to use something from that page going forward. So once again, find the email that invited you to this session, find the Learn More link, click it, leave that open in a browser tab, and let's continue. My name is Akash Sharma. I'm an IoT solutions engineer with ClearBlade. And as you already know, ClearBlade is a company focused on helping our customers build IoT solutions. Just as with every week, we have a lot to do, so let's jump right in. Let's talk about the project we've been working on. Then we're going to go through a guided development. Today's going to be a little bit different in that a large part of today, you're going to be watching what I'll do, and I'll tell you when I'd like you to follow me, so listen for that. And as always, I'll leave everyone muted till the last few minutes when we have time for questions and answers. So I appreciate everyone keeping their questions ready for me for that time. So let's talk about what we've done so far. Over the last couple of weeks, we have built a system that acquired an array of time and temperature data, saved that to a collection, and displayed that in a portal widget. Now, we said that we eventually wanted this temperature data to originate from some temperature sensor mounted to some asset that's important for our business. Now, as a placeholder till we get there, we've been using temperature data that we get from an endpoint published by the National Weather Service. This endpoint is one we can send requests to, and it returns several hours of temperature forecast data. And we've been simply taking that, storing it, and displaying it, and pretending like that is our asset data. Now, eventually, we're going to move towards getting that temperature from actual assets. In fact, we're only going to use that endpoint one more time today. And from that point on, we're really going to treat that temperature data as if it came from a business asset. Now, you can imagine if temperature data originated at a sensor and then made it all the way up to our widget, it had to traverse quite a bit of infrastructure. Now, a very important part of that infrastructure, in fact, I would think of it as the plumbing of our infrastructure, is a communications protocol called MQTT, which is an acronym, and you'll see what the acronym stands for very shortly. There have been several communications protocols that have been used for letting things in Internet of Things systems talk to each other, but MQTT is really emerging as the standard, the most performant, the most scalable. There's several reasons why it is the protocol of choice. In a nutshell, it involves a central broker that holds topics. There are clients that would subscribe to or publish to those topics. If you had one client publish to a particular topic and you had a different client subscribe to that same topic, now those two clients can talk to each other. That's the whole idea. What we're going to do today is to expand the system we've been building by building a new code service. This one, unlike the microservices that we built so far, this one's going to be a stream service. Its job will be to subscribe to one of these MQTT topics, and if there are no messages on that topic, it just sits and waits. If a message comes in, the stream service will take that message, take the data, and write it to our collection that we've been keeping so far. So obviously that data will be temperature data. Who would put the data into the topic? Who would publish that data? Well, for today, it's going to be us simulating a business asset. And eventually, in a future session, you'll see that that data will actually originate from an asset. Now, we're going to need to modify the widget parser, the code that sits behind our widget, because there's a limitation in it that you'll see as we continue. So at the end of today, we will have built a stream service that writes to our collection and updates our widget. Here's MQTT in a snapshot, central broker, clients that publish and subscribe. There's the acronym if you were ever curious. Be aware that ClearBlade builds its own broker that either conforms to or exceeds the requirements in the latest revision of the MQTT spec. We're going to learn about some of the rules regarding naming of MQTT topics today. Be aware that there are several more rules than what we'll cover today. You can find them in our docs, in the spec, and if you follow further sessions in this series, you'll learn about more as well. With all that said, please go to the page that you opened up, and in that page, find the link to Log Temperatures Stream Service. I would like you to right-click and open that link in a new tab. That's the completed version of the stream service we're going to build. Worst case, if you don't want to follow me, you can copy and paste the contents of this tab into the console window when we build it. And log into platform.clearblade.com and log in. If you have not registered, you will need to register. You don't need a registration key. And once you have your login information, go ahead and log in. And when you log in, you may have a system down here that you've already been building. So long as that system has been built up to the end of session 2, you can continue with it. If not, I encourage you to rename the existing system and get the completed system from session 2, which is available in the same page that we just looked at. So that's what I'm going to do. Go to that page. Here's a link to the zip file. Click to download it. And then, so long as you know where the zip file is, you can click on Add System, pick a file as the starting point, click here to browse to the zip file you just downloaded. Don't have to extract it, double click or select it. And when it gets uploaded, you have the system exactly as it was at the end of session 2. Before we run anything, let's make a few changes. I want you to go to Users. And notice I've provided one user that you can use to log into your portal. If you don't like this user, you can add your own. But if you do use this user, click on the gear, settings, and change the password to something that you remember and update. Great. Now we have a user we can use to log into our portal. Go to your collections, go to device 1 temperatures, and notice there's no data here. That makes sense. When we put the zip file together with a completed system from last session, it's unnecessary to pack in a lot of old data. We're going to get that data fresh. Go to your code page. In the code page, go to Get Temperatures Plural. And remember, when we ran this, it got the data from that weather services endpoint and saved it to our collection. So this is the last time we're really using that endpoint. Hit Save and Test. Now you're going to see success, road to collection, click done. Go back to your collections, go to device 1 temperatures, and notice that your data has come in. Now go to your portals, go to the portals page, go to temperature monitor portal. You're going to need to log in, so you can use a@b.c if that's what you chose. Do login with the password that you wrote. And now let's look at our widget. Be aware that this section of the video is actually being recorded after session 3 was completed, because in the original session there was an error in our suggestion for a modification for the data parser of the scatter plot widget. That error has been corrected here. So if you look carefully at the scatter plot widget, you'll notice that it is only displaying 100 points of data. But the endpoint that we retrieved information from actually provided us more than 100 points. It's something like 140 points. So there's obviously a limitation
we would want the scatter plot to show us 200 points up to. Not only that, we would want it to show the latest 200 points. And that's important because our collection will grow and we'll eventually have much more than 200 rows in there. So we would want this to always show the latest 200. The right way to achieve this is to modify our widget parser, but to also use a new component called an internal resource. An internal resource is either a JavaScript or CSS file that sits outside of our widget parsers, but can be used by all of them. And it gets loaded and executed when the portal is loaded. Our widget parser and that internal resource will communicate through a new data source called a local variable. So let me go ahead and create that first. I'm going to go to data sources, add a local variable, and it's going to be called plot data because that's what it's going to hold. It's going to hold plot data that the internal resource will retrieve and store here, and then our scatterplot widget parser will get it. And the local variable, as you would guess, is just a temporary holder of information to share just within the portal. So I'm going to go ahead and create that. Okay. Next, I'm going to go, and I'll keep saving the portal. Next, I'm going to go to the actual widget, mouse over it, click on the wrench icon, go to its data parsers, and I'm going to go ahead and change its data source from device1 temperatures to plot data, the new data source. I'll keep saving. Don't worry about the fact that this got confused. Right now, plot data has nothing in it, so the widget is complaining that that's not the format it needs. That's okay, we're going to fix it. So I'm going to go ahead and edit this, and I happen to have the completed parser. It's not that one, actually. It is scatterplot widget parser right there. And this should be attached to your video in some form or fashion. So take a look for this. And this is actually simpler than the parser that used to be here. So that's also good in a way. The parser should really do very little. So what it's doing is it's taking the incoming data from the data source and just extracting one by one for every element in the array. It's just extracting one item from it. It's fairly simple. So I'm going to go ahead and click apply, save it. And now I need my internal resource. So let me go back to home and go to internal resource and add. And I happen to have the internal resource as well. And this too will be attached to your video in some form or fashion. The internal resource is going to have this name, write plot data lock var. Write the plot data local variable. Write plot data lock var. There it is. Okay. And let's take a look at this code before we paste it in. First of all, I'm accessing the two data sources that are important here. One is the original data source, device1 temperatures, which is a collection, which is already defined in here. Then the second data source is plot data local variable, which we just defined. Then I have this function set interval. What is set interval? It's a JavaScript function that takes two parameters. It takes a function parameter and it takes an interval or period parameter. And once it runs, what happens is every that many milliseconds that elapse, this function is executed. So let's see what this function is that we want to have execute every 3 seconds. First of all, we create an object of class ClearBlade query. By the way, if you start with cb portal dot, now you can access functions that normally would only be available in our code services or libraries or stream services that we write within our backend console that you find over here. But we can actually access those classes, functions, and so on from the portal if you start with cvportal.clearblade. So we're creating a query object. What is this query object going to do? It's going to query our collection. And what is it asking for? It's asking for the data to be returned in order of descending valid time. Valid time was the timestamp column, if you recall. So we're asking for it in descending order of valid time. And then we're going to chop off the 200 of those. So we're chopping off or retrieving the latest 200 rows by timestamp. Then to actually get the data, the result data, we actually have to perform a fetch. And this fetch function takes a callback. The callback takes two parameters, error and data. If there's an error, we just log a message that nothing happened successfully. But if there's no error, we take the data that we got, which is the 200 latest rows, and then we reverse it. Why reverse it? Because it shows up in descending order. That's how we get the latest 200. And then once we have the latest 200, we want them in ascending order. And so we do this reverse, and then we call the data source right here, and we invoke a method of it called send data. And that's how we put the data into the local variable. So with all that said, let's go ahead and copy that, paste it here, save the file, save the portal, and sure enough, within 3 seconds, the data has shown up, and it is definitely more than the 100 points that we originally had. Now, I'm going to go ahead and look at the data sources. I'm going to see how often these are being accessed. See, the plot data is being accessed every 3 seconds. The way we had it in our original suggested solution, you would have seen that this the database collection would have been accessed an excessive number of times, putting a load on our system. So with this, this widget will always show the latest 200 points, and we're going to keep this as part of our solution going forward.
I'd like you to go to the code, messages tab, the messages page. And what I want you to do is to choose the test topic tab, and I want you to right click and duplicate this entire browser tab once, twice, and 3 times. So now you have 4 tabs that are all pointing to messages test topic. And now I want you to sit back and watch what I'm doing. 3 of these I'm going to use to just illustrate MQTT, and then you're going to follow me in just a little bit. So I'm going to use this first message tab as a client that both subscribes to and publishes to a topic, and the second and third are just going to be subscribers. The client that subscribes to and publishes to the topic, it's going to use this topic. Okay, I'm going to have that guy subscribe, and he's going to publish as well. The second one, subscribe. And I know I've subscribed because the button that said subscribe now says unsubscribe. Do that with the third one. Now the first tab is going to both publish and subscribe. The second and third are only going to subscribe. So I'm going to use this widget that I would normally use for publishing just to indicate which subscriber you're looking at. So there's subscriber A, subscriber B. Now I'm going to publish some data to this topic. publish. You see that subscriber A got it and subscriber B got it. That's how it works. Every subscriber that subscribes to a topic gets the message that gets published to the topic. Now let's look at the way the topic was named. You have these forward slashes that separate topic levels. The levels can contain a wide variety of characters, lowercase letters, uppercase letters, numbers, underscores, dashes, several things. Here's a couple of naming rules that we encourage you to follow. Even though you can, do not start or stop a topic name with a forward slash. Just use the forward slashes to separate topic levels. And even though you can use spaces in the levels, don't do it. Just avoid spaces. Okay, so now what I'm going to do is have subscriber A subscribe to a slightly different topic. I'm going to change the word football here and make that the wildcard plus subscribe. And I'm going to go to the publisher, and I'm going to have the publisher publish to a slightly different topic. So when I publish, you're going to see the message received by subscriber A because he's subscribed to anything that's STL cardinals at the two ends, but not subscriber B. Now I'm going to make subscriber B subscribe to STL/#. That is every level beyond the first forward slash is replaced by this wildcard. That's the difference between the pound and the plus. So now I'm going to go ahead and subscribe. I'm going to go to the publisher. I'm going to have him publish to a different topic called Arch. Free concert at the Arch. Publish. Subscriber A does not get it. Subscriber B definitely got it because he's getting everything for STL followed by anything. Okay, great. So we know a couple of the naming rules for topics. Now I'd like you to follow me on something. I'd like you to go to the first tab that you have open that's pointed to the messages test topics page, and I'd like you to subscribe to a topic called success. Subscribe, and I'm going to make everything I have look like what you have. Success, subscribed. Now go to the second tab, subscribe to a topic called processed message. All one word, all lowercase. There's a method behind this madness. And the third tab, I'd like you to subscribe to a topic called device/1/temperatures. Type exactly like that. So now we're subscribed to these three topics. Okay. Now the fourth tab that I had you open, we're actually going to use that to go to our code page. And I'd like you to add a new code service. So click add code. And this time it's going to be a stream service. And you'll understand the difference between that and a microservice shortly. Log temperatures, camel case, use that name, please. Create. Who's allowed to run this? It's going to be authenticated. Click on authenticated run, add permissions. The libraries that are here are all that we need for this stream service. Click away, click done. Our stream service shows up with some pre-built code that's very useful and very valuable to understand, because if you understand it, you can edit it to do exactly what you want. Let's take a look. Here's our main function. And then as soon as we enter, we initialize our ClearBlade object. We did this before. This is the object that we get from our ClearBlade library. And we essentially use that for a huge amount of functionality. Now we use that object and invoke what I think of as a constructor within it called messaging to create a messaging object. And I use that messaging object to subscribe to and publish to topics. And at line 19, you see we're subscribing to a topic called hello. Let's change that to device/1/temperatures. Save, Control S. Now, after the subscribe is done with its job, it calls a callback called wait loop. Now, if you look in here, this callback, if there was an error, it publishes a message to the error topic and it causes the stream service to just exit. But if there was no error, we should be publishing a message to the success topic with exactly this string. So let's see if that happens. I'd like you to hit save and test here. I'd like you to go to the advanced tab, and down here you see a refresh button. I want you to click that. And when you do, you see that there is one instance of this code that's running. Well, let me hit refresh again. It's still there. It hasn't gone away. This is very different from a microservice. Microservice comes up, does something, and then goes away. Not so with a stream service. There's something there that's keeping it alive. Now let's go to that first message tab and see if we got our success message. We sure did. There it is. Now you can close this tab. Now let's go back to our log temperatures and let's see what else is supposed to happen. Let's go to our code editor. And apparently after the success message gets published, we're supposed to enter this while loop. And here's where the magic happens. There's a function called wait for message. Its job is to wait for any messages that appear on any topics in this array of topics. I only have one topic in the array, but I could have several. If a message shows up on any one of these topics, I proceed. If not, I wait. Or if there was an error, again, I publish an error message and I exit. If there was no error and I get a message, what do I do? Well, apparently I execute process message. And what process message does is it publishes a message to yet another topic called processed message. And here's a string that includes the message that was originally received on the topic subscribed to. So let's see if we see that. Here, the second of the two remaining message tabs, you subscribe to device one temperatures. Right in there, some value into the publish widget and just hit publish and go to the first remaining messages tab where we subscribe to processed message, and sure enough, there is the received message. Our stream service did exactly what we were expecting. It received the original message from the topic it subscribed to, and it published a version of it to the topic that it was publishing to. Wonderful. Now, we don't want to just relay these messages. We want the stream service to do some real work, that is, write to our collection. So let's do this. Let's go back to our advanced tab and let's stop the instance that's running. Technically, you could edit the code without stopping the instance, but I just feel better stopping and then editing and restarting. So what I'd like you to do, you can paste the solution in here if you'd like, or after the messaging object is created, I'm going to create a new object to write to my collection, and that's going to be, oops, clearblade.collection takes one parameter, which is collection name, which has value device one temperatures. And now I can go back to processed message. I can get rid of what's there, or I can leave it there. And what I'm going to do is create a new row, which takes one JSON object as a parameter. The first column in my collection is valid time. I'm going to make a new date, take that. And the value column, I'm going to take the message and parse it as a float. So it is up to me to make sure that there's a floating point value in the message. Now save and test. Notice that we have one instance running. Now let's see, what am I going to publish? What am I going to publish to device one temperatures? Well, let's take a look at our temperature monitor portal. You notice that all the temperatures are falling between 20 and 30 Celsius. Maybe we publish 39. So I'm going to go back to where I've subscribed to device one temperatures, and right there I'm going to type in 39, publish. I'm going to go back to my portal And sure enough, there's my 39 as part of my data. Now you might wonder, wait a second, why didn't this show up at the end of the series? Why did it show up right here? Well, remember that the original data was temperature forecasts. So all these times are in the future. This is in the present. And you can verify that the stream service did exactly what you wanted, which is get the message from the topic and wrote to the collection. If you went back to the collection and you filtered and searched for values greater than, for example, 35, and when you look, you see, sure enough, there is one value. This is exactly what we wrote just now. In the future, in a subsequent session, we will have some other code that sits with our business asset and is getting the data from our temperature sensor. We'll have that code actually write to the topic, but this stream service will essentially do what it's doing right now. With that said, I'm going to unmute everybody, and if there are any questions, feel free to ask them. Thank you, everybody, for listening. All right, at this point, you should be able to unmute yourselves if anyone has any questions. So I will mention in a subsequent session, what we'll probably do is have some code that could be sitting on some embedded device that sits right next to your transducer, your sensor, thermocouple, whatever it is, receiving that data, and it will write to our topic. The first step will be for we'll have that code that's sitting on the embedded device write straight to the broker that's sitting in the cloud. And then in even further seminars, we will have that code write to a local broker that might be sitting right there on the device, what we call an edge, so that if you ever had network disconnections, that equipment can continue running robustly. So there's a lot we can do to expand on what we've done to this point, but you will see that MQTT is fundamental to all of that. So as with previous sessions, the video of this session and the zip file with the completed system will be made available. You know how to contact us. Here's our website. ipm.clearblade.com is a site where we publish what are called IoT package modules or IoT package managed modules, which are essentially systems built and available for you to use straight out of the box. And if you want to know more about us, feel free to ask us for a demo.
That was very good. Thank you, Akash.
Thank you. So I will stay on until 3.
3.
I'm sorry, 2:30.
Like
Sorry,
3.
2:30. Yep.
All right.
Or not. Okay. Thank
Yeah.
you.
Thanks. Let me.
Have a good one, guys. Thank you very much. And see you at the next one. Very much looking forward to seeing everyone back. Bye.